3 sessions or even 6 sessions. MATLAB is primarily a mathematical tool, and that is what we will teach you to use at the beginning. So we're going to start off by just using it for normal mathematics, and then on we might go into small types of applications of using MATLAB. The first few minutes of this session, they will be fairly boring, so try to keep up with me here, because first of all I need to tell you about data types, and then on I will try to show you how what I told you has been useful. I'll turn on the projector. Okay, so in today's lecture, what we'll talk about first is what are the data types supported by MATLAB, how does MATLAB work exactly, and we'll then try to go through some basic examples. So let's start here with the layout of MATLAB. When you open up MATLAB on the computer in front of you, you'll start off with this type of window. It has various functions. Each part of the MATLAB window or the layout has a various function. Here you have the editor, the command window, the current folder, and history and workspace. First of all, when you want to start learning MATLAB, you'll be working with the command window. The command window is basically like the command prompt in Windows. It's like this old black screen, if you remember it. You give it some commands, you type, you press on return, and then you'll get some output. As you can see, here's just like a calculator: 1 + 2, 1 / 2, 1 × 2, and 1 - 2. You can just give it random mathematical operations, and it will execute them right after you press enter. Now, this is not very useful if you want to do something complex, but it is very useful if you want to try something, just a one line or a couple of lines. The second window is the one that I showed you in the middle, the big one. This is the editor. The editor is where you'll be typing your code if you want to write something that involves hundreds, less than hundreds, more than hundreds of lines of code. This is where you'll be typing your codes. So, and after you finish typing your code in the editor, you'll be saving it as a .m file. MATLAB executes code that is written in the editor. It executes it left to right and top to bottom. So just like you read any text, it's the same way MATLAB will read it. Sorry. So this is obviously the boring part of MATLAB, which we'll need to go through. There's also the workspace in MATLAB. The workspace is actually one of the most important things for debugging. If you have a problem in your program, you always need to keep track of your workspace. Here will be all your variables and what their values are. So if you're running through a program, and you're having problems and you don't know what's wrong, you monitor the workspace to make sure everything is going all right and all the values of your variables are the same. Now, if you double-click something in your workspace, you will get something that looks like this. This is called the variable editor or the variable viewer. It will show you an Excel sheet-like window that has all the variables stored, all the values stored in one of your variables, and will tell you its data type, as you can see right there in the corner. The command history window is when sometimes you type something into MATLAB into the command window, and then it works, and then you don't know why. So in the command window, in the command history window, you will be able to see everything you typed for a fairly long period of time. So if you type something and it worked, don't bother trying to type it again. Look in the command history and you'll find it. Double-clicking it or dragging it, you will be able to use it again. The current folder window in MATLAB is the folder that MATLAB is working in. So if you want to use something in MATLAB, if you want to use a picture, if you want to use a curve that is saved as a mat file or some other thing that MATLAB can use, you need to navigate to that folder through the current folder window, which is usually on the left side by default on MATLAB. Now, MATLAB deals with variables primarily as matrices. When you want to assign variables and you want to keep track of them, you need to know that there's this variable called ans. The one that was there, it stands for answer. This is one variable you should stay away from as much as you can because it keeps changing its value. So just like when you use your scientific calculator, you press on answer and then add something. In MATLAB, this value keeps changing because sometimes you're executing multiple things at once. So do not depend on the value of ans. What we usually do is that we type a name of the variable on the left, just like you do it in normal mathematics, an equal sign, and then the value you want to assign it to. That way, you can keep track of it in your workspace, and you can call back the variable with that same name. So if you type x equals 2 in your workspace, that will always be x, and you change it to x, and then that's what to use. Try to stay away as much as you can, as I've said, from the variable, from the answer variable. And also, as you can see here, I've inserted something called a semicolon operator. Usually when you type things into MATLAB, it also repeats them in your command window and it gets annoying. So if you put a semicolon after what you type, the output is suppressed. The actions still happen, but the output is usually suppressed. Now let's go to variable types, right? We have in numbers in mathematics, we have integers and we have floating point numbers, which are like decimals, right? And we have doubles. So MATLAB also deals with those types. One of those examples is the integer 8. So it's a int 8, which is an 8-bit integer. You can have a value from -127 to 127. Usually the case is that MATLAB will take care of the type for you, but sometimes you'll face a problem and you need to have this in mind. It will tell you type error or something like that. This means that you are trying to, for example, store a decimal number in a place or a name reserved for an integer. MATLAB usually tends to take care of that for you, but if it does not, pay attention to that point. If you want to see more on the MATLAB variables and the variables it supports, in the help you can go to MATLAB, language fundamentals, data types, and numeric types. There are other types other than numeric types, like structures and tables. Those will be discussed probably in later lectures and used in later lectures because, well, they're not very widely used on the basic level of MATLAB. So, as we said, MATLAB stands for Matrix Laboratory, so it primarily deals with matrices and arrays. To define a matrix in MATLAB, or to make a matrix in MATLAB, as we said if we saw the x equals 2, yes, go ahead.
What's the matrix and the array?
The array in MATLAB is a one-row matrix. So if you have a matrix and you fill the first row, that's your array in MATLAB. That's the basic difference. You can have other types of arrays, like a cell array in MATLAB, but that's not included in today's lecture in MATLAB. So if you want to create a matrix, you can see here we have 1, 2, 3 separated by commas, but then the next one is separated by a semicolon. The semicolon part, the semicolon is to indicate we're working with a new line in the matrix. So once you type up a semicolon, it creates a new row in your matrix. So let's try it here and create a matrix A, right? So matrix A is 1, 2, 3, and then 4, 5, 6, right? If I do this, I have an array, a horizontal array, right? Or a horizontal vector that has 1, 2, 3, 4, 5, 6. But what if I do this between the 3 and the 4? Instead of the comma, I give it a semicolon, and then I have 1, 2, 3. I move to another row, and then have 4, 5, 6. One other way to do this is to separate the numbers on the same row by a space instead of a comma, right? So you'll see this interchangeably. If you're looking at the help, the documentation of MATLAB, or you're just asking around online, you'll see them use it alternately, which makes no difference. So I can say 1, 2, 3, and then 4, 5, 6. When you're dealing with the scripts or in the editor window, you can also use an enter, just a new line instead of the semicolon, right? So you can say A is equal to 1, 2, 3, and then 4, 5, 6, which makes it easier for the programmer to read it and tell that this consists of two rows. Yes, you can just press enter. Now, this approach is not really very it's not really good practice, because usually you have each line executing separately, but now you're defining a matrix in two separate lines, right? So if you have enough space to not do this, don't do this to not to confuse yourself, and stick to the space and semicolon combination, which is the easiest to understand, and it's the most common. Of course, this lecture won't teach you all of MATLAB. So if you get online and ask online about something in MATLAB, this is the one you will see the most used. The combination of a semicolon with a space is the most widely used practice. MATLAB can also, of course, do a lot of things with matrices. Now, it was first created to do complex linear algebraic operations. So we can take one of the few matrix operations we can do is the inverse and transpose, get the diagonal of a matrix or create a diagonal matrix, identity matrix, zero matrix, and ones matrix. Okay, so let's try each of those out. Let's say we have a square matrix of 1, 2, 3, 4. 1, 2, 3, 4, right? So this should give me a square matrix, correct? Does anybody see it because it's a bit low? Does anybody not see this? Okay, fine. I'll do everything here, but you can still do it in the command window. So if I say A equals 1, 2, and 3, 4. Now you can see in the workspace the variable A, and you can double click it, and it will open up the variable editor. And you can see it as an Excel sheet, just like I told you in the slides before. And if you want to get the inverse of it, just say inverse or inv A. And if you execute that, you will see your output in the command window, which is the inverse of the actual matrix that you've just entered. One other way to do this is the regular to power minus 1. In mathematics, if you say power minus 1, you mean the inverse of something. So if we type A to power minus 1 and execute that, you'll still get the inverse of your matrix. The transpose of the matrix is with it's just like a prime in mathematics. So you say, if I say A prime and execute that, you will see in your command window, you'll see the output as the transpose of your original matrix. This is probably very easy and boring, but you'll need to use that if you want to use anything in your linear algebra course or solving a systems of linear equations. The identity matrix is usually a very useful matrix in image processing, or the zero and the ones. The identity matrix is useful in linear algebra. So if I want to create an identity matrix and I want to call it B, I say I, and then I give it's a square matrix, so I give just one dimension. If I say 5 and I execute that, I will get a 5 by 5 matrix, which has a diagonal of 1. If I say B equals 1s and 5 again, I will get a matrix of 1s, which is 5 by 5. But the matrix of 1s also I can give it 2 dimensions, correct? Because it doesn't have to be a box usually. So if I say 5, 3, I will still get a matrix of 1s, and with the dimensions I have specified. You also notice that the first dimension is always the number of rows, and the second dimension is the number of columns. You can also do the same. The operation is identical with between the zeros and ones. It's exactly the same operations, but the zeros will give you a matrix of 0 elements. So if we say zeros, to give you the same thing, just a matrix filled with zeros. Yes. In the editor here, I'm writing everything instead of writing it in the command window, because the people in the back can't see what I write here usually. So I just write it here and execute it. It's the same thing. If you
write it in the command window.
Yes, that's what I said when I started. I said you can write it in the command window, but it's just because people in the back don't see. Or better yet, I will just move this here for everyone. Right, and I just open the command window like this. Still, it'll stay at the bottom, so it's probably useless. All right, so other operations in MATLAB between matrices. Now, those are operations you can do on 2 matrices. You can, of course, you can add and subtract and multiply and divide matrices. Let me define 2 matrices here, right? So let me say matrix A is, again, the square matrix 1, 2, 3, 4. And let me say that the matrix B is 5, 6, 7, 8. Now, if I execute this, I will save in my I will save in my workspace 2 matrices, right? A and B. Now, I can do operations on both of these matrices. So if I say I want to divide those two matrices, this is the division of both matrices. So now the answer variable is equal to matrix A divided by matrix B. And we can see that here. If you divide two things in MATLAB, you need to pay attention to this. If you divide two things in MATLAB, even if it's an array with a matrix with an array, you need to make sure that the dimensions match for matrix division, because this operator is not like normal division. Neither is the multiply operator in MATLAB. It's matrix multiplication and it's matrix division. Now, if you want to what if I want to divide every element in A to its corresponding element in B, which is called element-wise division, right? What you do is you insert a dot before the division. So this here you take it as not two operators, just one operator. So this operator here is called element-wise division. Likewise, this is called element-wise multiplication, right? So if I do this again and I execute, you can see the answer variable is 5, 12, 21, 32, which is 1 times 5, 2 times 6, 3 times 7, and 4 times 8. Is everybody clear with this?
Was it?
Yes, basically, but the dot product usually gives you a scalar, if I'm not mistaken. So this in MATLAB it's called element-wise multiplication, element-wise product. Yes, that's what they call it. Okay, and you can also now other operations you can do to matrices in MATLAB. Now, if the dimensions match, for example, if you have one matrix and you want to put another matrix next to it, correct? So this is called matrix concatenation in mathematics. It's useful when you want to solve a system of linear equations. What we usually do is we augment a matrix and put the row of solutions next to it, and then reduce it to reduced row echelon form. So how do you do this in MATLAB? There are two ways to do it. There's one, first, the intuitive way. So if I want to put those two matrices side by side, a 2 by 2 next to a 2 by 2 should give me a 2 by 4, correct? So if I say I want to have a matrix C that is A, comma B, right? We said we divide things on the same row with a comma, so just put those matrices next together in a row fashion. And if I execute this, you'll see that those matrices were put next together. This is the first one, 1, 2, 3, 4, and the next one is 5, 6, 7, and 8. So this is horizontal concatenation of two matrices. If I want to put them under each other, one under the other, I separate them with a semicolon, just like if I was creating a new matrix, and I'll have them like this: 1, 2, 3, 4, 5, 6, 7, 8, which will give me a 4 by 2 matrix. Again, I'm sorry if this is boring, but this is the basics of what we need to learn to further go in MATLAB. We can also create vectors. Now, if you want, for example, if you need to create something like a time axis or an x-axis on your plot, you need to create a vector for that time axis, right? And you can't go on typing 1, 2, 3, 4, 5, 6, 7, 8 till the axis ends. So you can use something called linspace. Let me clear everything here. And now let's say our x-axis, right, equals, we can use something like this called linspace. When you open up the bracket, by the way, in MATLAB, I'm sorry to tell you this, when you open up the bracket in MATLAB, if you type a function, open up the bracket and just give it a second, it will tell you what the inputs are, and then you can go on for more help. You can give it A and B, which are the starting and ending point, and it will choose the interval by itself. Or you can give it A, B, and N, where A is the starting point, so I want to start from 0, and I, for example, want to end at 30, and I want to do this in N steps. I want to do this in 100 steps, let's say. And if I execute this, your output will be like this: columns 81 through 85, 86 through 90. It will show you all the columns. So just to keep this neat, I will put a semicolon and then execute it. The output will not be shown. If you take a look at it in the variable editor, you can see that I started from 0, and after 100 steps, I reached 30, and the steps here are equidistant. So this is how you create your axis.
30 divided by 100?
Yes, but yes. Yeah, it's 30 minus 0 over 100. That would be your interval, right? Because it's a linear space. It's the increment is linear. It's always the same, and it's going to go to 30 from 0 to 30 in 100 steps. That's all there is to it. And there's also another way to do this. If you don't want to choose the number of steps, but you want to choose the width of each step in your x-axis or the axis you want to create, you can say, well, 0, and then I want to go in steps of width 0.01, and then go to 30. Semicolon. If you execute this, you'll see here it took us 3001 intervals to go to 30, and we started from 0, kept incrementing until we reached 30 after a very, very, very long time. There's also, we usually need to do plots on a logarithmic scale, if you've ever dealt with that. So if you want to do the same thing but with a logarithmic scale, instead of lin space, you use log space. So if I want to do this, log space, now in log space, the inputs, here it will say the same thing, but the inputs are formatted differently. Your starting point will be 10 to the power A, and your ending point will be 10 to the power B. So if I say from 0 to 2, I'll have a logarithmic scale that goes from 0 to 100. From 1 to 100, which is 10 to the power 0 and 10 to the power 2. And n, if I specify it, it's the number of decades that I want to reach this point with. Right. Done with this now. Now I'll access the MATLAB help for you, just to make sure you know where to go. If you press on Home on the top button, and you press on Help. Now, of course, I can't cover everything MATLAB does with matrices, because all it actually does with matrices. You can go to MATLAB, Language Fundamentals, Matrices and Arrays, and everything you will ever need to know how to do with MATLAB, you'll find it here with an example. So the things that I've just done are the most basic things you can do with matrices with MATLAB. You can still, of course, get the eigenvalues, the eigenvectors. You can diagonalize the matrix. You can get the LU factorization. All of that can be done with MATLAB, and there's probably a command for it. We'll show you examples later on, and that'll probably make it easier on you. Basic arithmetic, which we have just went through. Now let me go through a few examples here. Let's start with, we missed one thing, by the way. We missed polynomials, and I'm going to discuss that through an example, because it's a bit, yes, go ahead.
For the beginner session today, after what we're going to cover?
Fine. Today, what I'm going, this is the examples here are the last thing I'm going to cover. So this will take us till about maybe 6:15, and then we'll have a small break, and then we'll cover symbolic operations. So if you want to do regular calculus on MATLAB, when you usually do calculus, you do typing symbolic variables, symbolic integration, and differentiation. We'll cover that after the session, and that will be it. So some plotting will also be included here.
For the intermediate as well.
For the intermediate, we'll have more plotting, right? More numerical methods will be probably discussed. ODEs, ordinary differential equations. Probably
For tomorrow.
Yes, it's probably for tomorrow. And for the last session, we'll have 3D plotting and animation, modeling, control. We might actually have control tomorrow. Anything else? Yes, go ahead. That we will probably cover tomorrow. But if you want, we probably have time today. If you want, I can go through some of them today, if that's necessary, if you feel that's necessary. Sure, no problem. Okay, so let's first off start with what is everybody here knows what a polynomial is, right? X squared plus 2x plus 1 is equal to 0. So if I want to define this polynomial on MATLAB, if I want to say x squared plus 2x plus 1 equals to 0, MATLAB doesn't take x's and 2 times x's and 1's right away. So I need to define it as a matrix as well, right? So I say, first of all, I say that, well, 1, 2, 1. What this means is, well, since I have 3 elements in my vector, right? So this is the coefficient of x squared. This is the coefficient of x, and this is the coefficient of the constant at the end of the equation. So it's x squared plus 2x plus 1. Then I define my x-axis, as we have done before. I define the x-axis from -2 to 2 in increments of 1% or 1 over 100. Then I use this function called polyval, right? So polyval means, well, polynomial evaluation. So this evaluates your polynomial. Let me show you exactly how polyval works. If I have a polynomial saved as a row matrix, right? It's a row and it represents a polynomial. I say y is equal to polyval, and when you open up the bracket, it should tell you what to give it. So p here is a polynomial, and x is your x-axis. So x is all the points you want to evaluate your polynomial on. So I give the command y equals polyval p comma x. Evaluate the polynomial p on the axis x. Then I use the plot command, which is this is the most basic form of plotting, just 2D plotting. You give it the x-axis and the y-axis, right? And here down there, I'll show you what happens. So F9 here. So the first thing I did was I closed everything. I cleared my workspace. When you say clear, you clear everything here. When you say clear in your script, yes, go ahead. It's located in my current folder. It's not there. This is something I wrote. So I wrote in the editor. Okay. Yes. Okay. So I'll actually do it. Okay. I'll do it with you from the start. The polynomial example. So. Okay. So here we can say if you want to open up a new editor window, in your command window you can say edit. You press enter. So it will open up a new file. Now I want to define a polynomial, correct? So I start with, well, my polynomial, I want to call it p, and I want it to be x squared plus 2x plus 1, right? If I say here a 0, now I have x cubed plus 2x squared plus x plus 0. 0 is a constant. Do you understand this, everyone? Okay. So I want to keep it as x squared plus 2x plus 1. I finish with a semicolon because I don't want to see the output in the command window. And then I define my x-axis. My x-axis is -2 in increments of 0.01, and it goes to 2. Again, I finish up with a semicolon because I don't want my output to the command window, correct? Now after I define my x-axis, I define my polynomial, I want to define my y-axis. Every value on the y-axis is the evaluation of this polynomial at this point to the x-axis. So I say y equals polyval, open up the bracket, wait for the output, wait for the hint, and say, well, okay, then it's p and x. Actually, it's just a coincidence it's p and x, because it won't always show you p and x. So if this is z and x, I'll still have to write z here. Right, so don't type the letter that comes up in the hint. Type the letter that corresponds to this. Let's just keep it as p again. All right, and I also press the semicolon. And make the semicolon a habit if you are working with the editor window, because if you don't make it a habit, then you will cram everything down there, and you won't be able to read your outputs. Now I want to plot my y-axis against my x-axis, which is plot, and then x and y. And if you don't, now if you want to run your code, you go to the editor here, up, if you can see it, and you press on run, right? But you cannot run it if you don't save it. And it has to be saved in the current folder. So if you save it somewhere else and then you try to run it, it will say, do you want to change that folder, or do you want to add this to go to this folder, or what do you want to do? One other thing you can do if you don't want to save it, if you're just trying out, you can select everything, right-click, and evaluate selection. Right? A faster way to do this, if you want to do it really fast, you just press Ctrl A and then F9. F9 is evaluated. Right, so the plot comes here. We can see the plot, the x-axis is from -2 to 2, and we can see our polynomial. The polynomial has a double root at -1, and that we can see that it's a repeated root at the -1. We can see here it touches on 0 for some horizontal time. Now, what if we want to know the roots of our polynomial? That's usually the case. We have in mathematics. So you can say, well, okay, tell me the roots of this polynomial p. Intuitively, it's actually called roots, and then you give it the argument, which is your polynomial p, and you need to assign this value of roots to something, correct? So I say r equals roots. Now, when this executes, the function roots will take my polynomial p and store in the variable r the roots. Let me execute this again. And you can see r, I left out the semicolon after r because I want to actually see the output. So the r is -1 and the r vector is -1 and -1. So this means I have two roots at -1. One other way to define a polynomial, which is usually very useful, is you want to define a polynomial by its roots, right? So if I want to redefine this polynomial in another way, I can say p equals, there is a function called poly, right, which stands for polynomial. I can say poly, and now I'll give it the roots, right? I'll give it a vector of the roots. One second, I'll explain this right now. So here, poly is a function which will take a row vector that contains the roots of your polynomial, right? So this is a row vector here, which is given as an argument to the function poly, which will give me the polynomial. If I execute this, you'll see that the output is, this is negative. Sorry, I forgot the space here. And if I execute now, you can see I have the 1, 2, 1 that I had before. So, sorry, to further clarify this, let's say my roots are r equals -1 and -1. And now I can create my poly r, and I want to call it p. I'll still have the same output, right? My p polynomial is 1, 2, 1, which is x squared plus 2x plus 1. All right. Now you can also do the derivative of your polynomial if you want to plot that. So the derivative of your polynomial is also intuitively polyder. So it takes the derivative of your polynomial, and here at the last thing I show you how to define the polynomial just as the previous way I showed you. Now, if we want to go to another example in most of our courses in mathematics, we usually need to do a partial fraction expansion, which takes quite a long time most of the time. So the partial fraction expansion is something you usually do for when you have a ratio of polynomials, correct? If you have a ratio of polynomials and you want to do the partial fraction expansion, MATLAB can do that for you, and it's called the residue. The command here is called residue. One thing I want to comment on before I do residue or any other function is the reason I'm actually using these functions here is because I can't go through all of them and explain each function. MATLAB has over 1 million functions. So the way you learn it is the way you know what function you're looking for is you go to the help. For example, here I go to the help menu and I say partial fraction. And the first result is residue, right? Did everybody see that? Okay, so this is the most practical and the most useful way to use MATLAB or to learn what the functions are in MATLAB. So now I want to use this function residue to get the partial fraction expansion of a ratio of 2 of my polynomials. I did that in this example here. So my first polynomial is 1, 2, 1, right? And for the second polynomial, I use the poly command. Right? So my second polynomial is a polynomial that has roots at -2 and -3. And finally, residue gives you 3 outputs, right? Gives you r, P, and K, which are the zeros, the poles, and then the constant term. Let me run this, F9, and here you'll see R, P, and K, which will correspond to, if we're dealing with an S domain polynomial, or if we're dealing with, let's say, an X, not an S. So negative 4 and 1, so I'll have X plus 4, and I'll have X minus 1 over, not here, over X plus 3 and X plus 2, and then finally plus 1. This is how you interpret the R and P and K that are outputs of residue. What I've just explained here on how to get from the R, P, K to the actual partial fraction expansion is also explained in the MATLAB documentation, in the help menu in MATLAB. The next example I want to discuss is the LU factorization, right? So is everybody familiar with LU factorization? Okay. LU factorization is when you have a matrix, right? You have a square, not necessarily, I'm not sure if it's necessarily a square matrix. It's a matrix, and then you want to split it into one lower triangular matrix and one upper triangular matrix. Correct? This is usually done in numerical methods. Not sure. Okay, so this is usually done in numerical methods, the LU factorization problem. You can also do it in MATLAB. The command is very conveniently called LU. So you give it a matrix. I've used the enter combined with the semicolon here. I gave a matrix 1, 2, 4, 6, and then I said the lower triangular matrix and the upper triangular matrix are called LU, right? Are called L and U, and then I said, well, factorize my matrix A using the LU command into a lower and into an upper matrix. Basically, the job of the L and U matrices, if you multiply those two matrices together, you go back to your original matrix. So I also did that just to verify the results. Let me clear. Right, here's my L matrix, 1 over 4, 1, 1, and 0. My upper matrix is 4, 6.50, and then when I said L times U, the answer was 1, 2, 4, 6 again. Right? Usually, if you want to do this on your by hand, it usually takes a bit more time than this. One other example I want to show you guys is the trigonometric functions like sine and cosine. Right? MATLAB also does those, but it only does them in radians. So you don't change the units in MATLAB from degrees to radians. So if you want to get the sine of an angle, the cosine of an angle, or the sine inverse, the cosine inverse, whatever, you always need to use radians. I'm going to start by defining, of course, my time axis, because that's how we usually say we want to use MATLAB. We use sine or cosine function. So I'm using a sine function from time 0 to 2 in increments of 0.01. And this is the function I want to define, right? Cosine 2 pi t, which is 1 hertz cosine, 1 hertz cosine signal. I said, well, after defining this, I just define it as you would with cosine. Cosine is COS normally, and sine is SIN, and tan is TAN. But the inverse of them is the A sine, A cosine, and A tan. So for the inverse of it, you don't type the power to -1 here. You say, well, A sine, A cosine, and A tan. I'm going to do this. I'm going to plot the signal, plot the cosine, correct? And then I want to get the inverse of this cosine to see what's my angle, correct? And then I plot this again. I'll run this first, and then I'll go through the code step by step. All right. So if let me try to put them like this. Okay. Now, if you see here, what we did is we got the signal and we plotted. We got the wave and we got the angle. You see when it hits a 0, right? It hits a 0 when it's 90 here. It's the same x-axis, right? So this is just to make sure that we actually got the inverse cosine. Now, if you want to go through the the code itself, all right. First of all, I usually start with close all, clear CLC. This is just to delete everything I was doing before this. The clear, as I said before, it clears your workspace, so you have no variables stored, and the CLC will clear your command window, so it will be empty from now on. I created the time axis, right, and I use the cosine, and I use the plot, and then just to show you that it's an inverse cosine, so it's a cosine, and when I plot it here, if you notice, you can also do math operations on variables as you plot them. So when I plotted the time against y inverse times 180 over pi, which is converting it back to degrees. So you can also do a math operation on a variable while it's here. You don't have to first multiply it times 180 over pi and then plot it. All right. One last example is, well, I guess, yeah. And now this is a linear algebra example. So this is how to use the reduced row echelon form to solve a matrix. I think I'll do this again. I'll repeat this example, right? So if I have this matrix, let me write this on the board actually. Okay, so matrix A here is, we have these three equations: x plus y plus z, and we have y plus z, and we have z equals. We have 0, 3, 1. 0, negative 3, and negative 1. The solution is very obvious. I know that because z is negative 1, and then you put it here and put it here. It's very obvious. But now, how do we do it like we do it in a normal linear algebra course, right? We take this matrix. It becomes 1, 1, 1, 0, 1, 1, and 0, 0, 1. We augment it with this row, with this column, sorry, and we say 0, negative 3, and negative 1, correct? And then if we take this to reduced row echelon form, so it needs to be an identity matrix here, we'll end up with the value of each variable on this last column, correct? So what I've done here is I've defined the matrix exactly as that one, the first matrix, right? I said 1, 1, 1, 0, 1, 1, and 0, 0, 1. Separated everything by a semicolon as usual, and then ended with the semicolon. Now this last column, I said 0, negative 3, negative 1, and then I give it a transpose. If you take the transpose of a row vector, it becomes a column. And then what I did was I concatenated them, so it's basically matrix augmentation, and then I used RREF, reduced row echelon form, right? And the output matrix will be very illustrative of the fact that it's a solution, right? The output matrix is 1, 1, 1 on the diagonal. Everything else is 0, and then this line will be 3, negative 2, negative 1. So this will be x, this will be y, and this will be z. This is exactly the same way you would do it on your hand, but instead of having to go through the reduced row echelon form operations, you can do it here on your. You can do it through MATLAB very easily. What else is to discuss in these examples? I'll show you a small thing, which is functions, right? Don't worry if you don't. Yes.
What is R?
What is R? What? It's not R reference. It's a function in MATLAB, right? Reduced row echelon form. If it's you probably did you finish your linear algebra course? Yeah, so you probably forgot it. It's when you take a matrix, when you want to solve linear algebra.
This function
yes, it's in MATLAB. It does this for you. After you give it this matrix, it will do this method for you. It's actually a function, because a command is like plus a function is what you pass it something that gives you an output. Right? Go ahead. Sorry. Okay, so this is slightly advanced. This will be useful if you want to make something, for example, if you want your sine to always be in degrees, right? So what do? We create something called a function. This is a sum. I'll edit it right now. So we create something called a function. If you start your script with function, and then you example underscore function. This is the name of the function. Here are your input arguments, and here are your output arguments. Is anyone here? Did everyone here take a basic programming course? Any kind of basic programming course? 1, 2, 3. Okay. Functions are like, for example, a small box, right? You give it things, and it gives you things out. Okay. So I want something to give it an angle in degrees, and I want to get back the sine of that angle, right? So I say, well, okay, I want to define something called a function, and it will give me out the, let's say, sine value, right? This is what it will give me out of it. And then I want to call it sine degrees, or sine underscore d, and it will only have one argument, right? Which is the angle in degrees, correct? Now, everything you do here is exactly the same as you do it normally in MATLAB. And you can use this number in it. So when you call it, you can use this as if it was previously defined. So now I want to say sine value, which is my output, basically. Sine value equals sine degrees times pi over 180, right? Now, if I say sine d, and between brackets 90, sine underscore d, between brackets 90, it will give me out 1. Let's see. Here, one thing you need to take care of is this needs to be called sine d as well. Right? So now if I say sine underscore d 90, it gives you 1, right? What happened here is I gave it the 90. It went in here. It says, okay, well, this value is 90. Now do this and put it in this value. So take the sine of this, the value that you were just given, multiply it by pi, divide it by 180, take its sine and place it in sine value. This is the basic. This is the most basic function you'll ever have to do. Usually the functions are a bit more complex. That's it for the most basic things today. We'll take, I think, a break right now for Maghrib prayer. Is it Maghrib time or no? Oh, okay. Adnan, if you want, you can start with your.
How do you put the input?
You put the input of, again, tell me.
The function, how do you give it the input?
The input was this is the input of the function, right?
From the command.
Yeah, I gave it. I called it from the command. You can call it wherever you want, in the command window or in another script. But what you need to keep in mind is that the function, as I said, needs to be in your current folder. MATLAB does not see anything beyond your current folder, unless you do something else and add it to path, which is a bit more advanced. But if you have the function here, you can use it in your scripts or in your command window. You can do whatever you want to. Okay.
Let's open some questions.
Yeah, if you want, guys, if you want questions, you can. There are 15-20 minutes for questions. So if you need something like really specific from MATLAB, you can raise your hand.
Yeah, we can go around and help you.
Can you create the function and save it? How to save the function?
Save the function? Okay, fine. I'll create the function much slower now. So if you go to home, right, and go to new, right, and function, right here, and you have everything ready for you, almost. So now here you place you say what your outputs are called, and you say what your inputs are called, and each of them, of course, you divide them with a comma. So let's do this again. Here I said it's my sine value, and here I said it's my degrees. And in this part I said, well, sine value equals sine degrees times 180 over, times pi over 180. Right? And then you change this name here. This is very important, by the way, for MATLAB functions. You change this name, and when you save the function, you need to save it with the exact same name. So it needs to be sine underscore d, because here it is sine underscore d in this part. sign underscore D here. When you save it in your folder, it needs to be signed. It needs to also be called sign underscore D. And overwrite. Okay, other things? If you have something a bit specific, okay. Change the font. By the way, can everyone see? Or is it the font too small? This is a bit too late to ask. Make it bigger? Sorry. عدنان من غير الفونت عجب الفونت
Guys, if you have any specific questions, we
Yes.
can go around and help. Please raise your hands. If you have any.
Is this better? Good. Oh. Is this fine? Guys, if you have also no questions, there's water, drinks, and some food outside if you want to go take a break. And again, if you have questions, even if it's like regarding something really specific, we can go ahead and ask. If you're asking about a specific numerical method or a specific function in MATLAB or how to do something specific, you can go ahead and ask us, and we'll walk around and help. Just raise your hand. Everything that I did on the PC is recorded, and it's still recorded. I'll give you a website that has the recordings and slides. Right up. Yeah, we'll have more than and then you just do exactly what I did. All the you look for the operation
that's okay. Good point.
You do it on math.
So you don't put this for the years, but here you use DEG, doesn't understand that. So you either go, yeah, this has to be degrees or this has to be DEG. Get what I mean? Okay, now hello everybody, my name is Adnan Susi and I hope you're all fresh and ready to learn more about MATLAB. My colleague Sharif Anani just explained how you can solve a normal polynomial equation, something like x squared plus 2x plus 3 equals 2 or whatever. What if you wanted to solve something like ax squared plus bx plus c equals to 0? Can you do that on MATLAB? Yes, we can use the symbolic toolbox of MATLAB. Now the first step before using a symbolic toolbox is that we have to learn how to define symbolic variables. And to do that, we just type in sims, and then we put a space bar and then the name of that variable. And I'll show you quickly how to do that on MATLAB. So you go here on your command window, type in sims, okay, something like a space b space c x, okay. So you can see here in your workspace, you can see this little cube next to each variable, indicating that's a symbolic variable rather than an integer or any other matrix. Okay, so sorry, just let me type it in again into my editor. Now, I think that all of us would like to use something like that to solve equations, something as simple as a quadratic equation. So let me define my function. Let me call it fun, okay, equals to a times x squared plus b times x plus c. Okay, I think that most of us are familiar with the solution to this equation. It's negative b plus or minus radical b squared, etc. So let's see if MATLAB will give me that answer or not. To solve it, you simply use the function solve. Okay. And then the first argument of that function is the function itself, which I want to solve, and then the variable for which I want to solve, let's say x. And by default, it will take that function equals to 0. Let's say I want to equate it to something other than 0. Let's say 1 or 2. You just put equal, equal. Okay, in this case, I want to keep it 0. Okay? So this is my solution. Let me run this code. And it gave me my negative b plus or minus radical b squared minus 4ac over 2a. Now, as you can see, this does not look really nice in here. So I'd like to present it in a more pretty way. So use the function called pretty on MATLAB. It's actually a function. Okay. And here it looks very nice and beautiful. Now, other things you'd like to use in the symbolic toolbox is a different calculus functions that you have, like differentiating a function, integrating a function, etc. Let's try to differentiate a simple function. Again, the quadratic function that you already have. Okay, do that again. So the diff 1 equal, and I use the function called diff, which stands for differentiate. Okay, differentiate fun with respect to x. Now, if I want to find the second order, I just put a comma 2 or a comma 3 or whatever. I can just enter the order of differentiation. What if I have another variable into it? Let's say y. So I can put comma y instead of comma x. What if I want to differentiate it with respect to x and then with respect to y? Then I put just comma x, comma y, something like that. Is it clear to all of you? You have any questions? Okay. So run it. Let's see. So you can see it's b plus 2ax. And that's pretty nice. Okay. Now for integration. So again, I want to integrate my function. I use the command int, which stands for integration. First argument, again, it's fun, which is the function itself. And then the variable with respect to which I'm integrating. And then I insert the first limit and then the second limit. So let's say comma 0, comma 1. These limits can also be symbols. They can be a to b or lim1 to lim2 or whatever. Guys, did I lose you're all with me, yeah? Welcome. Okay, so this is the solution. Okay. And again, you can also use numbers. It's a symbolic toolbox, but we don't have to stick to symbols. We can use something like x squared plus 2x plus, let's say, 1. Okay, and it will solve that. Yeah. Okay. If you can see over here, it gave me the value in 7 over 3. What if I want the decimal value of it? I don't want it to be written as 7 over 3. So I simply type in eval, which stands for evaluate, before my integration or before any value. Let's run it again. I got 2.33. Okay. Guys, are you all good with it? You all understand this? Okay, it's clear. Okay. Now sometimes I have a system of linear equations, like the one in here, ay plus bx equals to f, cy plus dx equals to e. What if I want that written in the matrix form? We commonly use that in linear algebra, if you all know. So let me show you how to do that in MATLAB. Just let me write it. Where's it? Marco. Oh, sorry. Thank you. I have something like ax plus by equals to c, dx cy equals to f, and I want to write it in this format. Capital X, this is the matrix which contains all the variables equals to B. This is the matrix which contains all of the constants. This contains all of the coefficients. Okay, we can do that using the symbolic toolbox by using a very simple command called equations to matrix, and I'll show you how to do that. So first of all, we enter the two equations we have, and we put them between two square brackets. Okay, so the two equations we have over here are ax plus by equals to c. So I'm typing ax plus b times y equal. Again, I use equal instead of equal because this tells MATLAB that these two sides are equal to each other. I'm not assigning any value to one of the sides. We usually use one equal sign whenever I want to assign a value to a variable, but here I'm just telling MATLAB that these two sides are equal to each other. Okay, and then I put a small comma, and then the next equation, in this case it's d times x plus e times y plus the f. Okay. Oh, sorry, equal, yeah. And then I tell it what are my two variables. Yeah. Sorry? No, it doesn't matter. If you put a space, it won't affect. It's okay, you can put it, you can just ignore the space. And then I tell it what's my variables. In this case, it's x and y. There's a little mistake I've done over here. I forgot to define my variables. Here I have e and f, and they're not defined up there, so I just define them again. E, f, and d. Okay. Y, yeah, and y. So let me run it. Okay, so as you can see here, this is A. A is the A we have over here, and B is the B we have over here. And X in this case is XY. Yeah. Most of you who know linear algebra are familiar with this notation. Guys, please tell me if you have any questions. Okay, please. Okay, I'm really sorry. That's okay. Do you want me to repeat anything up until now? You're okay. Okay. So here again we can find the inverse of a function. You know, if a function relates a certain domain to a range, then the inverse will relate that range to the domain. So let's do it on the symbolic toolbox. MATLAB. If you have a function, let's say like a function, new function equals to a times x. So its inverse can be found by simply using this function. It's called I function. Let me make sure, sorry. Yeah. F inverse. Okay. F inverse of. Okay, let's run it. It should give me x over a, obviously. Put my semicolons over here. I don't want to see all of that. Okay. So yeah, it's x over a. That's inverse. The last thing that I'm going to teach you with the symbolic toolbox is how to solve ODEs using the symbolic toolbox on MATLAB. Let's assume we have this equation, which comes from an RC circuit. I think most electrical engineers are familiar with this equation. Anyways, it doesn't matter. You can solve any ODE with the symbolic toolbox on MATLAB. Okay. So one more thing we need to know here. Whenever I define a variable, which is in fact a function, let's say the voltage here is a function of time. So when I define it, I write it as follows: V, and then between two brackets I put in T. Okay? No. Whenever I want to tell MATLAB that V is a function of time, then that's how I type it in. I put V and then between brackets T. Is it clear? Yeah, let's say y is a function of x, so I'll put it like that. Okay. So after that, let me type in my equation, all the variables. Equals to so the first thing is you have to do is that you have to put in your equation, and then you put your initial conditions after that. Okay, and again here diff v represents the derivative of v with respect to time, because it's a function of time. That's what we told MATLAB beforehand that v is a function of time. So whenever I differentiate it, it will understand that I'm differentiating it with respect to time. Okay. Let me type it in. Equals R times C. Oh, I'm sorry. So remember the equation. Times C times V prime plus V. Okay. And then I tell it that my V0 is equal to 5. Okay. Sorry. Huh? Ah, so it's a small letter V, capital letter. Oh, sorry, just a second. I think we have a problem over here. Yeah, sorry. Okay, so this is the solution. Again, if I want it in a nice pretty form, I just use the function pretty. Okay. So that's all about the symbolic toolbox on MATLAB. You can use it for many other things. If you want to explore this symbolic toolbox on your own, just type in doc in the command window, and then go to the symbolic toolbox. Symbolic, where is it? Yeah, symbolic math toolbox. And then from here, you can explore the different functions that this will offer you, the different tools that that can be used. Okay. So if you have any questions, I can answer. Yes, please. Any questions? Yeah. Equal. Again, I'm just telling it that this is equal to that, but I'm not assigning any value. That's how MATLAB understands it. That's just the syntax. Okay. Guys, any other questions? Sorry. Okay. Yeah, to that. Okay, is that clear? Any questions I can ask?
Why do you like equations to matrix? Equations, why do you use this function?
Some people like to put in a matrix form. Let's say, yeah, there are state space equations, and you want them in the matrix format, you can use such a type of function. Some people might need it, you might not need it. But you understand how we can use it.
Yeah, I got the idea.
Yeah.
I was wondering.
Any other questions? I think it's pretty simple because that's how we usually write it on paper. So it's easily to understand, yeah? That's it. Thank you all for being here today, and hopefully we'll see you next time with more about MATLAB.
I want to show you guys a small function in MATLAB, because we understand that MATLAB is pretty boring and math is pretty boring most of the time. There's a very cool function we like to use in MATLAB most of the time. It's called y. Not the letter y, but y. So if you say y, MATLAB will usually just give you things that the programmers were bored and they just felt like doing something like this. And sometimes when you're bored, it helps. I mean, if you're writing something and it's just not working with you, sometimes it helps. So if you type, and each time you type it, it gives you something random, and this itself mathematically is not very easy to do, to give random output each time. So if you just keep typing y, and y, and y, and it will just keep telling you more stuff. Now, if we still have time. So somebody had a question about loops, about the syntax of loops. Since loops will be covered in the next lecture, the person who asked already has a programming background, so her question was mostly about the syntax of loops and conditions in MATLAB. So the way I'm going to explain what is a loop in MATLAB now kind of depends on if you know any other programming language or not. Just a brief introduction for people who don't know any programming languages. A loop is where you put something you want to execute all over again for a certain number of times, or sometimes forever, or until something happens. So if your question, for example, was about a for loop, right? The for loop in MATLAB is pretty easy. So even when you define the variable the first time, unlike in C, you have to define it as integer C, right? Here you can just say I equals 0. And then you want to say, well, I want to have 10 iterations, and each time I want to increment this number I. I want to add 1 to I, and I want to display it. I want to output it. So I say for I equal 0 to 9, or 0 to 10, or whatever you want. So this operator in MATLAB, if you remember the linspace, right? We used it in linspace to create an array of things. So this will also, what it will do is that it will say for I equals, and then this is an array from 0 to 10, correct? So, or it's a small vector from 0 to 10. So it will say for I 0 to 10, and you can see it automatically indents the code. It means that this is what will be done inside this loop. And let's say just and I just want to display the number I, right? And then end. So that's how you execute a for loop in MATLAB, and then each time it will give you the output, right? I equal 1. You can see here now, each time it executes this, it moves to the next element in MATLAB. So when I say 0 to 10, let's hope this works. It's like I'm saying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So each time it will do everything between 4 and n, replacing I with the next value. So it will start, first time, I'll do everything here, and this variable I, if you use it, its value is 0. And then the next time, okay, I'll do everything here, but now I is equal to 1. And it keeps doing this until it reaches 10, and then it goes out of it. There's also the regular, like, you can also break out of a loop using break, the same as in C++, I think. You can have a while loop. A while loop keeps doing something until something else happens. So you give it a condition. You say, for example, while I is less than 10, keep displaying, okay, fine. We can do this with the function. We can do this with the function y actually. So let's say while I is less than 0. This is very intuitive. I is less than 0. I mean, you write it just like you write it on your notebook. And let's say here I want to call the function y, the last function we used, right? So, and then after I call it each time, I want to say I equals I plus 1, right? So now, first time I is equal to 0, right? Oh, sorry, here I is less than 10, right? So first time I is equal to 0, right? And then what I would want to say here is I want to call the function y, and then make I equal to 1, right? Now it will go back, it will check, is I less than 10? It's still less than 10, so it will do it one more time. And it will add 1 to I again, until I is actually 10, right? It won't execute it because because the condition is not met. So if we run this, we'll call the function y 10 times in a row. So does everybody is this good enough for now, or if there's something more you need, you can go ahead and ask. If. Okay. Yeah, an if statement. Of course. So okay, I'm really sorry, guys. I will recover this in tomorrow's lecture. This will be done again in tomorrow's lecture. This is important also for numerical methods. If you want to assess the error, right? If you're calculating some error, if your error goes above something, then you want to stop and say, well, my method is diverging. If your error is below something, you can say, well, good, I satisfy my error now. But okay, so let's think of an example for an if statement. An if statement will take an argument, and it will see if the if condition is met. So if I is less than 10, then do this. So for example, now I want to say I is equal to 2, right? And here I want to say if I equal to, right? If I is equal to 2, I want to print this. This will be covered later on. This function fprintf will just print text in there, right? And now if this, then say, well, I is equal to 2, right? And then you say else, right? Well, then else will execute if it's not the same. I'll just print printf. Well, I is not equal to 2, right? And it doesn't matter if you put the semicolon because it's a print command. It has to show everything in the command window. And then you also end this, or you cannot end this, but usually we use that, right? So now if I execute this, it will say I is equal to 2, right? But if I put 1 here, it will say I'm sorry. Yeah. It will say I is not equal to 2. Alright, so this is an if statement. There are also a lot of other ones you can look at. The case statement, the case logic. It's not here. I'll open up the help and I'll show you where to go there. Alright. You can just type if in the help and it will show you else if and else. And this is under programming and functions. You can see here where the mouse is, right? This is under control flow as well. So you type control flow. Control flow basically controls how your program, how the data flows through your program. So all of those are there. The break, the continue, the else and else if, try and catch, everything is there. If you have previous programming knowledge and you want to. We will go through some of this in the second lecture to make you understand it. But of course, as I said before and say again, you can't cover MATLAB in a 4-year course. So we'll just cover as much as we can. And if you guys have anything else, you can ask. Yes? Oh, sorry. Yes, tell me. Block diagrams are a Simulink property. They're not specifically in MATLAB. They're two separate, almost two completely separate products. I will use them in the control systems lecture. Not today, because tomorrow we're expecting a lot more control systems students, and we're trying to teach everybody MATLAB. And if I go into transfer functions and block diagrams, not everyone here is an engineer, and not even all engineers use them. So I will cover some of the control systems probably in the third lecture, maybe tomorrow. But I won't go into Simulink that much. I will do control systems in MATLAB specifically. I will do root locus plots. I will do PID design, filter design, some of that. But when it comes to Simulink, we might cover Simulink at the end of the last lecture, just to show you guys that you can actually do something really cool with MATLAB. But again, I hope this answers your question. Go ahead.
In the loop you put I, but now we put something more complicated like add, distribution.
You can put for example when you want to do something that operates on a physical computer or something else. Sorry. I actually place the whole code in a while one. I want to keep it running, right? So you can put anything, any kind of code you want in your loop. But if you want your loop to finish, be sure that it's not an infinite loop. I think you have this from Maple, right? Sometimes you have an infinite loop and you keep calculating while it's diverging. That's because you didn't set your error to 3. Right? Anything else? Other questions? Oh yeah, yeah. Go ahead. Okay. You're asking all the questions I want to cover later on, but no problem. Okay, now there's some. Okay, this will be specifically to her because this is literally like we're not concerned with how to add a toolbox here, but supposedly you downloaded a toolbox, correct? A toolbox a toolbox is a collection of functions like the sine and cosine, for example, right? Those are two functions, part of what you can call the trigonometric toolbox for MATLAB. So usually every function in MATLAB, if it doesn't belong to the product itself, if we go here, right? So all the functions in MATLAB are either belonging to MATLAB, Simulink, which is the one with the block diagrams we're not concerned with, or one of these toolboxes, right? So when we say when we were talking about the polynomial that we defined as symbols, just like we do it in a notebook, that's part of the symbolic mathematics toolbox here, the symbolic math toolbox, right? So now she's asking how to add a toolbox, a custom toolbox. If you want to add a custom toolbox to your MATLAB installation, first is you go to Home here, and you go to Set Path. Can you see it? Okay, so if you go to Set Path, now when you download the toolbox, what it will be a zipped file or a compressed file or something like that. You unzip it or uncompress it somewhere in your computer where you will know it will not be touched by anyone else. And you will not want to go touch it again. Okay, so you put it somewhere else, and then you go there and add with subfolders, right? You navigate to the folder where you extracted it. For example, you go to this folder AMD, and you click on this, and then you click Select Folder. Now, all the functions that are in that toolbox, you can directly call them in MATLAB. That's the basic way you can install a toolbox. Now, some toolboxes, they come with help functions. Yeah, like they come with documentation as well. If the toolbox was a modern one, if it was made in the past 2 years, let's say, it will also show up in the help here. It will also show up here, if the people who made it were professionals, or if it was made in a modern day, like maybe 2 years ago, because this started from MATLAB 2012. Go ahead. Yes, those toolboxes here are toolboxes I have installed, right? Yeah, if it's not here, then you don't have it installed. All right, and sometimes you go online and you find somebody's using a function in the symbolic math toolbox, but your installation of MATLAB doesn't have the symbolic math toolbox. You can go ahead and buy it from the MathWorks website. But as I said, everything in here it's installed. If it's not here, it's not installed. That's from the stock MathWorks supplied toolboxes. There's a toolbox, I hope we can show it on the third day, which controls a robot, the Lego robot, if you've ever seen it. So there's a university, RWTH Aachen in Germany. They had a project where the students actually made a toolbox to operate this robot from MATLAB, and it's available online. I'll probably try to show it to show you how to install it on the last day. I'll show how to install this toolbox and how to do a few commands on this robot. Yeah, that's it about toolboxes, and if you want to use it. Yes, you extract it and make it a regular folder, not a zip folder. So you put everything into one folder and include it with subfolders, not just the folder itself. Just press on it and select folder. So it will include all the functions that are in there. And it's well, no. If the toolbox was made for a version after 2009, 2009A, probably not B. If it was made after 2009, it's still compatible with MATLAB, with the new ones. But if it was too old, there are probably some functions that are not there anymore. Some functions were replaced by other functions in MATLAB. Like in maybe I think a future release in MATLAB, you will not be able to solve an equation using inverse A times B. You'll have to use another operator, which is the right division. Because MATLAB does this faster. What they do is they release it and then they wait some time for the users to get used to it, and then they take it away. They take the old one away. But for now, I think any toolbox you'll find online will be safe to use with any release of MATLAB. Except if you have a very old one. Anything else? All right, thank you. And yeah, and by the way, the right way to learn MATLAB is not exactly like coming to. Well, you should come here if you want to learn MATLAB, but coming to lectures like this will not teach you all of MATLAB. You learn MATLAB either from this help documentation, or I recommend a website called Stack Overflow. I'll write it on the board for you. Right. StackOverflow.com. Now, this website is filled. It's a huge community for professional programmers, and if you ask them a question, they will more than welcomely answer you. But the problem is they assume most of the time. It's not actually the problem. It's how it's supposed to be. They assume that you know some MATLAB. So if you learn some MATLAB and then you go through the help, and then there's a huge community, and any question you will have has been probably asked already on Stack Overflow. So you can just go ahead and read it and read the questions there. You can search for the questions there. I will. What was the website? We made a website for these lectures as well. Give me about the domain. It's it's a free website on Wix, so you have to type my name. And then what was the crash course or workshop? I'm not sure. Okay, all the material here and even the video that we're recording right now will be available here. I'll make sure about the website spelling. I'm not completely sure. I'll make sure after the lecture. I'll send you an email right away, like in 10 minutes maybe. And there's also a discussion part on the website. So if there's something, again, you don't understand from the examples, or if you have some MATLAB code you don't understand, you can go ahead, post there. I will probably answer you. Adnan maybe will answer you. Any of the other lecturers will answer you, or you can answer each other in there. But the problem is you need to have a Facebook account, because that's how the commenting works on that. If you don't have one, I'm kind of sorry, I can't read your comments. Anything else? Right. Thank you.
Okay, everyone, if you didn't take attendance, we're making certificate for everyone who attended. Just make sure you wrote your name, or someone took your name for you.